Welcome back to Data Science for Humans. Today we're going to be taking a look at structured query language, also known as SQL. So this is a language you can use to communicate with databases, and we're going to show how to communicate with databases using R. So what the heck is this SQL thing? You may have heard of it a few times, but SQL is what's referred to as structured query language. This is a common language to communicate with any relational database. Now, it refers to a standard, which was standardized by the ANSI Institute in about 1986, and there's a lot of different variants of SQL. So Microsoft has their own version called SQL Server. Oracle has their version. There's lots of different versions available in the workplace, but generally when you're talking about SQL, you're talking about a server of some sort. So generally, you would not run SQL on your local computer. You would be accessing a remote SQL server somewhere else on your company or government network. Just to be clear, SQL refers to the language, but informally, we sometimes refer to relational databases like Microsoft SQL Server or MySQL as SQL. What we will focus on is how to get data out of a database using the SQL language. And specifically for our examples, we'll be looking at the popular SQL server known as MySQL. At the beginning of this recording, I said that SQL is a type of relational database. So what is a relational database? Well, a relational database stores its data in something called tables, and these tables have rows and columns. So this sounds pretty similar to what we've seen so far with data frames, doesn't it? Our data frames have columns, and there are rows of data. And each of these columns can have different data types. So for instance, if we wanted to store somebody's age, we could store that as an integer, a whole number value. If we wanted to store somebody's name or a country name, we could store that as a character value. Say we wanted to store GDP in millions of dollars, and we need decimal points. We can use floating point or double precision numbers for that. One slight wrinkle is that relational databases have something called an unknown value or a null value. This represents a value that is not known. Now, it's possible to define a column that accepts nulls, so a column can be created and it can accept a null value, but it is also possible to, when a column is created, when a table is created, to say that that particular column cannot contain null. And finally, in a relational database, where we get the relational part from is that we can define strong relationships between tables in our relational database. So for example, we can say that one table strongly refers to another. In our example, we are taking some data. We are taking data from the World Bank, and this is available at data.worldbank.org. This data has been exported to CSV and loaded into a MySQL database. So this data contains a number of country world development indicators for Canada, United States, United Kingdom, China, South Africa, and Brazil. Our database has two specific tables. The first is called country metrics, and this contains our actual measures. We have 4 columns. First is our country, second is indicator, so the specific economic indicator. The third is year, starting around 1960, depending on which indicator you're looking at. And finally, the value, which is a decimal value of some sort. Our second table is called indicator type, and this stores a name and a code for each of the indicators. So for example, we can see that we have an indicator for fertilizer consumption, percentage of fertilizer production, and the code AGCON-FERT-PTZS, or agricultural land. So these two tables are actually related to each other, and we'll take a look at these relationships in a little bit. For the moment, let's talk about these tables. Again, we have rows and columns, Technically, if you're getting really pedantic about it, we store these values in what are called tuples. That's getting into more math theory, so we can ignore that for now. Each column, again, has a type. The most common types that you will see are integers, or int, for whole numbers, float or double for decimal values, or varchar or nvarchar for text. Now notice for nvarchar I have a 200 in brackets. What that says is that no value in this column can be larger than 200 characters long. Some databases, in fact almost all databases, support saying nvarchar and then putting in brackets the word max, which basically means you can have a more or less unlimited character size in that column. And finally, you can have what's called a primary key on a column, or a primary key on a table, and that uniquely identifies a specific row in a table. So, for example, in our database, we may want to uniquely identify a row in the indicator type column. So we would specify, most likely, our indicator code as our primary key. The primary key is what we're going to use to establish a relationship between two tables later on. Now remember, this is theory right now. This is what I'm describing to you: tables, rows, column data types, and primary keys and relationships. These are all things that a database designer would choose and design for you ahead of time. The reason I'm giving you this background is so that when we query these tables or go to pull data out of these tables, you have a bit of an understanding how SQL servers work. So our primary key is a way to uniquely identify a single row. Usually, depending on the database you're using, depending on who designed it, usually some sort of a number or an integer will be used as a primary key. And you'll usually see either an ID or a key as a suffix on the column name. For example, country ID. However, it is possible for primary keys to be compound. So in other words, you use two or more columns as your key. And this combination of values uniquely identifies the row. And that's crucial about primary keys. This is how you identify a specific row in the table. As I mentioned, tables can also have relationships. We refer to these as foreign key relationships. Why do we use these? We use them to do fast lookups of values. We use them to also, and most critically, ensure data integrity. Going back to our database, for example, in our country metrics table, you can see that we have indicators like TM, val, MR, CH, R6, ZS. The way that we've defined this table is that we have a foreign key relationship between the indicator column on the country metrics table and the indicator code on the indicator type table. Now what this means is that every value that appears in the indicator column in country metrics, in our country metrics table, must appear in the indicator type table. And our foreign key refers to the primary key in our related table. So just to highlight this again, our country metrics table, our indicator column has a foreign key relationship with the code column in the indicator type table. That's enough theory. Let's pull some data out of our SQL database and manipulate it in R. There are two methods that you can use to query tables in R. One is called dbReadTable, and what this will do is read every single row from that table into R. Notice I've got two exclamation points next to this. I'm emphasizing that this reads all rows because most databases are designed to handle hundreds of thousands, millions, possibly billions of records. Generally speaking, you do not want to query the entire database when you are working with databases. Why? R will slow down, R might crash, and if anyone else is using that server, they're going to have a very slow or bad time. It's much better to use the db-get query because this allows us to write a SQL query that specifies which values or which rows do we want to return from our SQL server. So again, always use db-get query. Otherwise, you might overwhelm your machine and have a really bad time with SQL. How do we query this data? We've been talking about SQL queries. Let's take a look at the SQL query that you will use 99% of the time. It is something called a select statement, and it goes like this. First, you type in select, you specify the columns you want to return, then you write from, and finally, you specify the name of the table you want to read from. Ready to see it in action? So am I. Let's do this. I've now switched over to R. And in order to query from a SQL database, you need to install the R MariaDB package. Now, I've already installed this package, so I'm ready to just import it using my usual library command. So first thing I'll do is I'm using Control-Enter on Windows. You can use Command-Enter if you're running on a Mac, and I will import this library, MariaDB. Now, the next 4 lines, I'm specifying the username and the password used to access my local MySQL server. This will change depending on which organization you're working for. So ask your system administrator what info you'll need to actually connect to your SQL server. So my user and password is PS699 and finally PS699 secure. The name of the database I'm accessing is called World Bank. That's the name of the database that was set up for me that contains my 2 tables, country metrics, and indicator. Finally, DB host is where on the network or where on the internet this server lives. This server happens to be running on my local machine, so I'm using the special host name called localhost. If you're working for an organization, you might see something like mysql.mybigorganization.com or something similar to that. Your administrator, again, will give you the name of the SQL server. For my purposes, I'm running locally, so I'm using localhost. So now, on line 10, I'm going to open the connection to MySQL. So I use the dbconnect command, and I specify that we're using MariaDB, my DB user, the password, the name of the database, and finally, where on the network this database lives. So let's open that connection. Now the connection is open to MySQL. At this point, in this gap that I've left, we're ready to run some queries. When you're done working with SQL Server, remember to call db-disconnect with the name of the server variable that you've defined. Mine is called WorldBankDB. It is good practice to disconnect from a server because most SQL servers have a limited number of connections that you can open. And if you forget to close those connections, you might have some issues reconnecting to SQL Server later. So we'll just disconnect, and now we're ready to reconnect. All right, I'm going to go back to line 3 and rerun all this stuff and reconnect to the database. Let's run our first query. And again, we are going to use the special db-get query command to query our database and use our select statement. So I'm going to get my list of indicators first. I'm going to create a variable called indicators, I'm going to say db-get query. First parameter db-get query, I have to specify our connection variable. So in this case, I'm using WorldBankDB. And then our second parameter is the statement. So check this out. I'm going to use double quotes to write this statement. This will expect a string. And in this case, I'll use double quotes. And the reason for this will be clear in a little bit. First, I write select. Now, there's a shortcut to get all the columns. Remember, we had to specify the column names that we want to access. So select column 1, column 2. There's a shortcut if you want all of the columns. You can use the asterisk or star character. So we do select star. That says we select all our columns from, and our table name is indicator. So Here's our query. Select star from indicator. And if I run that, you'll see that now I have a data frame. Check it out, a data frame, 1,599 observations of 2 variables. And check it out, I have indicator names and the indicator codes. Isn't that cool? As you can tell, we have almost 1,600 observations. We have 1,600 rows. That's a lot of data that we're carrying over the wire. We can use something called a where clause at the end of our select to narrow down the data that we want to bring back. So let's give it a try. Our indicator table has a column called indicator code, and I'm going to narrow down our list of values to one specific indicator. And in this case, I'm going to use the indicator code of the amount of broadband internet access per capita. So I'm going to use where. So at the end of this, I'll use where, and then I'll specify indicator code. Now what's interesting is indicator code in our table has a space in it. So I'm going to use the backtick character, which is located on the top right of your keyboard. It's with the tilde character. It'll be right next to your 1, where indicator code equals, and then I'll put in single quotes the string that I want to search for. And in this case, it's it.net.bbnd. So check this out. Indicators equals dbGetQuery. Now look at this. Indicators is down to 1 row, our fixed broadband subscriptions. So this where clause is how you can limit the amount of data that you're bringing back to your local computer. Remember, SQL servers can store hundreds of thousands, millions, possibly billions of rows. Bringing all of that back can be very expensive. In your where clause, you can check for equality using the equals sign. For less than and greater than, it's your typical less than or greater than sign. You can do less than or equal to by combining the less than and the equal to symbols, or greater than or equal to, combining those 2 symbols. We can also check for null or not null. Now you might wonder, why would we check for null by using is null or is not null? And you might be wondering again, what the heck is this null thing? Let's take a moment and review Boolean logic. This is something we've seen in R and Python before. And when we're filtering our data, we're thinking in Boolean terms. In other words, we're trying to see if something is true or false. Say we're filtering on a range of years. We could filter on years where the year is greater than 1978 and the year is less than 1985. So in other words, as long as the year is greater than 1978 and the year is less than 1985, for example, if our year is 1983, those 2 conditions are true, and so the result is true. Or we can combine these values together by using the OR statement. But fundamentally, we have 2-valued logic. The answer to all of our statements is either true or false. But what about this null thing? In SQL, we use something called 3-valued logic. We have true values, we have false values, or we have unknown values, null. So is null true or is null false? Well, the answer is yes. It could be either. All null means is that the value is unknown. So why does this matter? Say we query our database for the employment rate in Canada in 1997 and the answer comes back as null. What does this mean for your analysis? Well, it's an unknown value, which means you can't make assumptions as to whether or not it's 0. Be careful. This is where people get tripped up very commonly, is they interpret null as 0. Null is not equal to 0. Null only means that the value is not known. I repeat that. Null only means that the value is not known. It could be 0. It could be 5. It could be 100. It could be any numeric value. But we don't know what the value is. When you are conducting your statistical analysis, you will need to take that into account. How will you treat and handle nulls? Not very different from how you've treated and handled not a number or NA values in your data frames. Null falls into the same category. Whether you interpolate the value by using a smaller value or a flag value, whether you set it to 0, or whether you drop those null records entirely, that is up to you, but it's a value judgment that you have to make as an analysis. So far, we've been looking at the indicator table. Now let's change our attention and look at the country metrics table. For our first attempt, I'm going to create a variable called country indicators. And I'm going to use that db read table just to show you how much data we're going to return. So I'll use the world. I have to specify my database connection, and then I specify my table name, which is country metrics. And choose on that for a couple of seconds, and you'll see that I've returned 217,000 observations, 217,000 rows. That's a lot of data. And remember, this is a fairly small database as far as databases go. One mistake that I ran into when I was preparing this demo is I was trying to merge these two tables. And what happened was I ended up getting a cross product, exhausted all of my memory, and R crashed. And my computer crashed at the same time. We'll gloss over that detail. But at this point, check this out. We could use merge to combine these two tables. So how do we do that? We could create a new data frame called merged data and use our typical merge command. We'll use our X table as country indicators. Our Y table will be indicators. Now I'm going to specify my by.x to be, and let's just double check this country indicators. I'll use that as I'll use the indicator column as my X column to join on, and by.y equals indicator code. And there's a space there. So here we go. We should have merged data. And check it out. We filtered this data down. Remember, merge is only going to return rows that have matching values in both tables. So I've filtered down from 217,000 rows down to 112. Now keep in mind, this is now happening locally because I've downloaded this data to my local computer. You can see, now I see for 2005 in China, there was this many fixed broadband connections. In Canada in 2017, there was this many. How cool is that? We've managed to pull data from a SQL database and merge it together into a data frame in R. So at this point, you can conduct the rest of your statistical analysis. You could run your ordinary least squares regressions. You could do further data cleanup. Heck, you could even export this to a CSV file and then import it into Excel or Tableau and do some more work on it there and do some visualization work. So there's lots that you can do at this point. And keep in mind, you've just scratched the surface. We've used a simple select command. You've used a simple where clause to get data out of a SQL table into R. So at this point, you have everything that you need to query SQL databases. The most common SQL query that you're going to run is a select query. And remember, that has the format select your column names from a specific table where certain conditions are met. The other three big commands are insert, delete, and update, but they're a bit outside the scope of this course. For your analysis, generally speaking, you will be selecting from a specific table or a series of tables, and you will be working with that data locally. Before we wrap up, let's take a look at one more type of query that you can run. While we've got this connection open, notice how so far what we've done is we've queried the indicators table, and we've queried the country indicators table, the country metrics table, and then done our merge locally. Now we pulled back a lot of data, around 200,000 rows. We could conduct this join at the database level and only return the data that we're interested in. So check this out. Watch what we're going to do. I'm going to create a new variable called joined data. and set this equal to db get query, specify my SQL connection, World Bank DB. Now check out my query. This is how I would typically write a query like this. We're going to be selecting from our country indicator table, our country metrics table. But check this out. I'm going to put a C next to it. What I'm doing is instead is when I run my filters, because I'm joining these two tables together, instead of having to type out the entire table name over and over again, I can refer to this table by C. Now, I'm going to join the indicator table to the country metrics table, and I'm going to specify which columns I'm going to join on. So I'm going to specify that I'm going to join on i.indicatorCode equals c.indicator. So I can refer to country metrics using C and indicator I because I put C next to country metrics, and I put I next to indicator. I'll continue. Check this out. Let's filter this down by the internet broadband, and the country is equal to Canada. So now I'll specify where i.indicatorCode is equal to, and I'll put this in single quotes, and I've enclosed the entire query in double quotes. Use indicator code equals it.net.bbnd and c.country for the country name equals Canada. Check this out. I'm going to run this entire query now. And you'll see with join data, I get back 20 rows with 6 variables. Notice that the indicator and indicator code, we've got repeating values here. We've got 2 columns that return the same value. What if I only wanted to return the country column, the year column, the value column, and the indicator name column? Well, check it out. I can do just that. Instead of using the select star, I'll now do select c.country, c.year, c.value, and i.indicator name. And notice I'm using this backtick because this column name has a space in it. Now notice that join data has gone from 6 variables to 4 variables, and I've only got the country, year, value, and indicator name. How cool is that? Thanks for joining me on this video. Next time, we're going to take a look at how to query SQL using Python. Talk to you later.